Hey guys, how's it going? Mr. Mitchell here. In this video we're going to look at free body diagrams. So let's get started. Now, free body diagrams can be useful when dealing with Newton's second law, but they can also be applied to lots of other situations. So what is a free body diagram? Well, it says that free body diagrams are used to analyse the forces acting on an object. The name and size of each force is labelled on the diagram. This enables us to calculate the resultant force and then apply Newton's second law. So let's look at a simple example to help you understand this. So it says that a small plane of mass 1,200 kilograms flying through the air will have four forces acting on it: thrust, drag, lift and weight. Here the vertical forces are balanced, so the plane will fly at a constant height. However, there is an unbalanced force of 3,000 newtons to the left acting on the plane, so it will accelerate to the left. So looking at this free body diagram here, you'll see we have the four forces labelled and their values written there as well. Now, you don't always need to write the values, but you're better off doing that if you do know what the values are, because that can help keep you right if you've got it on a sketch. So here you'll see the downwards force on the plane, the weight, and the upwards force, the lift, have the same values, so they just cancel each other out. And we've got a thrust force to the left of 3,400 newtons and a drag force to the right of 400 newtons. Remember, drag is just another word for air resistance. So if we wanted to calculate the acceleration of this plane, we could do, because we know that the vertical forces are going to cancel out, and we know that there's an unbalanced force to the left of, as we said, 3,000 newtons. And that's found from the 3,400 minus the 400 newtons. So that gives us 3,000 newtons to the left, and that gives us our unbalanced force F. So we can calculate the acceleration using Newton's second law, F equals ma. So if we rearrange for the acceleration, we get A equals F over m by dividing both sides by the mass there. And we can substitute in the values to get 3,000 for our unbalanced force, divided by the mass we were told in the question, 1,200 kilograms, and this gives us 2.5 meters per second squared. Now remember, acceleration is a vector quantity, so we want to state a direction with the final answer. So we've got to the left here as our direction, because that's the direction that the unbalanced force was moving in. So lastly, I've just put here, remember, acceleration is a vector quantity, so it needs a direction. That's all for this video, folks. I hope you found it useful. If you did, give it a thumbs up, subscribe to the channel, and I'll see you in the next one. Take care.